Hello, in this lesson we are going to talk about integration by parts, the second fundamental tool for the calculation of primitives. The objectives we aim to learn are to remember the concept of integration by parts and knowing how to apply said technique. The necessary requirements are essentially knowing the concept of primitive and the immediate primitives. We are going to try to deduce the expression of the integration by parts, in other words, the actual formula of integration by parts. If we write a function f as a product of two other functions, like a product of u multiplied by v, as we can see, we can first derive that function. It is observed with the known differentiation rule, the derivative of the function f would be the expression we have there, the derivative of u times v without further differentiating u multiplied by the derivative of v. This formula is the foundation of integration by parts, which essentially involves isolating one of the two terms that we obtain. If we leave only the summand u for the derivative of v and the rest we leave aside, we clearly see that I have substituted the function f by u multiplied by v. With this new notation, we can now transform derivatives by writing the derivative of u or the derivative of v as the partial derivative of u with respect to the variable it pertains to, and similarly the partial derivative of v with respect to x. This notation is primarily a matter of convenience and it only serves as insight. If we now multiply the whole expression by the dx, we would obtain this new expression, which is a little more complicated. Now, we can integrate across all the terms. This would lead us to find that the integral of u with respect to x times dv is exactly equal to the integral of u times v derived minus the integral of v times dv. Let's observe that the first of the expressions in the equality, which is the integral of u times v derived, the derivative of the integral would go away, therefore only u times v would remain, and that is the main advantage of using this method. After doing all this, we obtain the well-known formula integral of u times dv, which is the same as u times v minus the integral of v times du. Let us see a practical example of the integration by parts. A fairly simple example could be the integration of x times e raised to x. In what situation should we apply integration by parts, and why is this a simple example? Integration by parts is applied whenever we have two functions that are fundamentally different within the integrand. In this case, we have x, which is a polynomial, and exponential, which is clearly distinct from a polynomial. Therefore, these two functions cannot be treated in the same manner. We know that when we differentiate polynomials, they become simpler. When we integrate them, they become more complex. In contrast, whether you differentiate or integrate an exponential function, it remains unchanged. These characteristics are crucial for understanding how to apply integration by parts and when to apply it. The main idea is that we will use integration by parts when we want to integrate a product of two functions that have no direct relationship to each other. For example, x is clearly not the derivative of an exponential function. Well, in order to apply integration by parts, the very first step is to identify which part will be u and which will be a dv. In other words, we must identify the parts of the u dv as we mentioned earlier. The u is going to be something that we want to derive, and the v is something that we want to integrate. So in this case, we take as u what we want to derive, which is the simplest thing to derive, the x, and we take as dv the remainder, the e raised to x, which is what we are going to integrate, and that raised to x, when integrating it does not get complicated. Let's observe that what we are taking here is not v but dv instead, and therefore what we take here must be with the dx. That is quite an important thing we must take into account. Once we have chosen what will be u and what will be dv, what we proceed is to calculate the next two terms. From u, we get the du, which is simply to derive the derivative of u would be the derivative of x. The derivative of x is worth 1, and that is why we get du and dx. And as for the v, what we have to do is integrate it. V will simply be the integral of the exponential e raised to x dx. Therefore, we could say that the integral of the exponential is no other but the exponential itself. It's important to emphasize that we are differentiating u and integrating a dv. Therefore, the choice of u and dv is crucial. Once we have identified u, dv, du, and v, we can proceed to apply the formulation. Applying this formula, we have that the u dv, which we already had in the exercise, the u dv is always the initial integral, is going to be equal to u times v x times the exponential minus the integral of v times the dv, the udv on one side, and on the other side the rest of the formula. Let's simplify this result a little bit. Let's see that when we apply the formula, the first of the summands is left with no integral, but the second of the summands is left with an integral. That is to say, we are simplifying the initial integral, but in exchange we obtain another integral that we have to solve. It could turn out to be simpler or more complicated, but we aim for this to be simpler, and in this case, it turns out being simpler indeed. We get the integral of the exponential, which, as we have already said, is the exponential, and we would obtain this result. This result is the final one. To simplify it further, we can factor out the common exponential term, resulting in the last expression, which is the solution to the exercise. Well, this was all the content for today's lesson. From now on, we should be able to apply the method of integration by parts, and after this class, we should have learned something very important. Hopefully, we begin to understand that integral calculus is not an exact process where you have to follow exact rules. In contrast, I like to think about it more like an art, in which one has to develop their intuition and techniques that, depending on the situation, may be necessary or not. Thank you all, students. It's been a pleasure. Have a great rest of the day.